In this video, we will be discussing photoelectric effect, a brief historical context of the discovery, the experimental observations, and Einstein theory to explain the experimental observations. And there are no prerequisites to understand this video. So here is the experimental the photoelectric effect. So this is an evacuated tube, and this is a metal electrode. There is another metal plate over here, and these two are connected with an ammeter and an EMF denoted by V. So when light is incident on this metal, current is observed. So note that this tube is evacuated, so there is no conduction, there is no conductor to conduct electricity when any EMF is applied. But only when light is incident on the metal plate, current is observed. So you can parameterize the light by two quantities: the intensity, suppose I, and the frequency F, and let the ammeter reading be A, and V is the EMF that is applied. So we have three parameters that we can change: the intensity, frequency, and the voltage. So in the photoelectric effect observations, the following observations were made. So for every metal, there exists a particular frequency F called the threshold frequency. The threshold frequency for that metal is the frequency of the radiation below which no photoelectric effect is observed. So if the radiation is, if light of frequency lower than the threshold frequency is shined on the metal plate, irrespective of how high the current is, there is no observed photoelectric effect. There is no observed photocurrent. Second, there is a voltage called the cutoff voltage. So this is the direction of motion of the current. So it is V. So when the voltage is, when negative voltage is applied, so the photocurrent decreases. So it decreases to a certain point where the photocurrent becomes zero. So at a particular voltage, opposing voltage, the photocurrent becomes zero, irrespective of what is the current. And this cutoff voltage V is directly proportional to the frequency. The magnitude of V is directly proportional to the frequency. So higher if you double the frequency, the opposing voltage that you need to apply to stop the photocurrent will also be doubled. Saturation current. So when the frequency and the intensity of the radiation are kept fixed and the voltage is increased, the photocurrent increases and it saturates to a particular value, and this saturation value is directly proportional to the intensity of the radiation. The saturation current is directly proportional to the intensity. And the last point, the time for observing the photocurrent after shining light is negligible, of the order of nanosecond. So now let us look at the existing theory, the electromagnetic continuous radiation electromagnetic theory. So according to that, the radiation is a continuous form of energy. So to observe for electrons to be released from the metal, the metal should absorb the radiation for a certain amount of time till the total energy absorbed will exceed the energy, the binding energy for the metal. So irrespective of what frequency you apply, if you increase the current and you have the radiation for sufficient time, the energy that will be absorbed should be sufficient to release the electron from the metal plate. So according to the continuous radiation theory, there should exist no threshold frequency. So if you see the plot of the photocurrent A versus the voltage V, so the plot would look like this. So these are plots where the current is where the frequency is constant. If the frequency is constant, there's a particular threshold frequency below which no photocurrent is observed, and these are successively increasing intensities. So when the intensity is increased, correspondingly the saturation current increases. And when the ratio of intensity by frequency is kept constant, the saturation current remained the same, but the threshold frequency kept decreasing. So this is increasing frequency. So these are the plots that are observed experimentally, and the classical electromagnetic theory was not able to explain the existence of a threshold frequency. So Einstein proposed a quantum theory. So he said that the radiation does not consist of continuous energy, but it exists in discrete packets called quanta. So each quantum has a particular energy. The energy is proportional to the frequency of the radiation, and it is independent of the intensity. And more the intensity of the radiation, there are more quanta in the radiation. So the intensity is proportional to number of quanta per unit time per unit area. So we'll see how the Einstein theory is able to explain the photoelectric effects observations. So matter absorbs the energy as discrete packets. So unless Einstein said that unless the energy of the quantum exceeded the energy required and exceeded the binding energy for the electron would not be released. So the proportionality constant was later called the Planck's constant, E is equal to hf. So unless hf is greater than the binding energy of the electron, no photocurrent is observed. And for a particular intensity, there are certain number of quanta per unit area, per unit time being incident on the metal plate. So the number of electrons cannot exceed the number of quanta that are falling on the metal plate. So the saturation photocurrent is dependent only on the number of quanta. That is proportional to proportional to the intensity of the radiation. So the duster.
किती वेळ लसानी
3 minutes. So this is how Einstein's theory explains the photoelectric effect, while the continuous electromagnetic theory was not able to explain it. Thank you.